Alright, assalamu alaikum guys. This is for the lesson on Monday. I'm just doing a catch up here. So basically we're going to be looking at linear graphs, and like I said, we're going to progress through plenty of graphs moving forward. And you just need a few techniques in order to sketch all of these. So let's just get started here. So follow these steps for the linear function y equals 2x minus 2. Find the y-intercept by putting x equals 0. Find the x-intercept by putting y equals 0. Plot these intercepts and hence sketch the line. So these three questions are basically an instruction on how to find what a line would look like on a graph. So y equals to 2x minus 2. First thing we do is we get the y-intercept, and we do that by letting x equal 0. So the y-intercept will become 2 times 0 minus 2, which equals to negative 2. So therefore, this is our y-intercept. And then the second question is letting y equals 0 to find the x-intercept. So we're going to say let y equals 0. We have 0 equals 2x minus 2, 2x equals 2, and x equals to 1. So this is the x-intercept. Now, just using some logic here, in order to draw a straight line, I only need 2 points. And in this case, the x and y-intercept are the perfect 2 points to find because they're both very easy to calculate. And 2 points is more than enough. So watch what we do here. Now, I'm only doing approximation. I'm not doing exact. X equals 1 is around here. Y equals negative 2 is around here. And we just need a line that goes through both of these. All right, and extend that like this. Extend that like this, and just make sure you're going through everything, and that's it. This is the line y equals to 2x minus 2. That's how you sketch a line. So easy, so straightforward. Just find the x-intercept, find the y-intercept, plot them, sketch the line. All right, on to the next one. Now, what we just did previously, that generally works when you have when you've got an equation. Like if I do x and y-intercept technique on this, I'm going to get the same point, so it's not going to really help us. So if constant is absent, it's better to just find a second position. So it'll make more sense when I actually do it, because look at this first question. Show that x and y-intercept are both 0. So that doesn't help us because that's one dot. I need 2 points to sketch my graph. So let's just look at that. So we're going to say let x equals 0. We get y equals minus 2 times 0, which is 0. So that's the y-intercept. And let y equals 0. We're going to get 0 equals negative 2x. And if I make x the subject, I'm going to get y equals 0 again. So that didn't really benefit us in any way, because if I were to plot this on the graph, I'll just quickly do that here. If I put both points here, well, how do I know which way the line is going? Is it going this way? Or is it maybe going that way? It's hard to tell. Okay, so that's not enough. And this will be question B. Well, actually, B will start over here. Because look what they tell us. Substitute x equals 1 to find a second point. You can substitute any second point that you'd like just to have something to draw through. So let x equal to 1 in this case. We're going to get y equals negative 2 times 1, which is negative 2. So essentially what I found here is a point. And the point, 1, negative 2, is specifically what we found. Okay? So 1, negative 2 is down here. So I have 0, 0, which we found in the first part, 0, 0. And now we have the point 1, negative 2. Make sure you're going through both. And that's it. That's the line y equals negative 2x. So we use this technique when we don't have a constant on our linear equation. I think one other important thing, how do we recognize a linear equation? Well, basically a linear equation has no power on the x or the y. Well, it does, the power is 1, but there's no power bigger than 1 on the x or the y, and you can see that with all of these. All right, look at this. The whole topic is linear, and you can see the x and the y both have a power of 1. Okay, let's move on. So the next question is, determine by substitution whether or not the given point lies on the line. So all we do here, we substitute this as x, this as y, and then we check that the equation balances. So we're going to put y as 1 and x as 3. So we get 1 equals 3 minus 2, 1 equals 1. This balanced, therefore 3, 1 lies on y equals x minus 2. So when it doesn't balance, it means it doesn't lie on the line. Let's check this example to see if it balances or not. So here x is 7, y is 4. We're going to substitute them in accordingly. So we get 4 equals 20, take away 2 times 7. 4 equals 20, take away 14. 4 equals to 6, which is not true, so it didn't balance. Therefore, 7, 4 does not lie on y equals 20, take away 2x. So that's the difference here. That's all we're looking for. Okay, so hopefully that's nice and easy and clear to everyone. Let's move on to the next section. Sketch the following vertical and horizontal lines. So this is nice and straightforward as well. Just as a note, horizontal lines are in the form y equals a, and vertical lines, I should probably, logic tells me to swap it the other way. Give me a second. I should do a vertical first. Vertical lines are of the form x equals a, and horizontal lines are of the form y equals b. So you can tell this is a vertical line because it's x equals something. This is a horizontal line because it's y equals something. Now I'm going to sketch both graphs on the same axes. Actually, let me use a bit of a grid. Let me label this. I'm going to do every second value here. All right, there we go. So now with this, I'm going to sketch x equals 1. So x equals 1 means I'm looking on the x-axis, as you can see here. This is the x-axis right there. This is the y-axis. So x equals 1, I'm going to go across to 1, and I'm going to draw a vertical line through 1. That's x equals 1. And now I'm going to do a horizontal line for y equals 2. Because y equals 2, as you can see, is in this form. So it's a horizontal line. Y equals 2. And that's it. All right, so you just have to apply what we've done here to these types of questions. All right, moving on. Consider the lines x plus y equals 5 and x minus y equals 1. Graph the lines on a number plane using a scale of 1 centimeter to 1 unit on each axis. So if you're doing it on paper, try and use the correct units. Part B, read off the point of intersection of the two lines. Confirm your answer to part B by solving two equations simultaneously. Now, what I'm going to do, I'm just going to bring this down a bit so I have a big enough grid to use. So let's put in our grid. somewhere. I obviously have to do the setup, but I'll make it big enough so everything's clear. So we have x plus y equals 5. And to sketch this, I will do the x and y intercept approach because we have constants, we have numbers. When we have a constant, you can use that. So let x equal 0. 0 plus y equals 5, so y equals 5. This is going to be the y-intercept. Let y equal 0. We get x plus 0 equals 5. X equals 5. This is going to be the x-intercept. All right, so let's bring this closer now. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, I have to watch this. Ugh. I should just do every second number or something. 2, 4, 6, 8, 10. I know I did. I know I'm wasting time, but it's all right. Minus 4. Minus 8. Minus 10. Minus 2. Minus 4. Minus 6. Wait. Minus 8 and minus 10. All right. So now we have our y-intercept at 5. That's around there. Our x-intercept at 5. And we're going to draw the line here. But don't do it like that. You have to extend the line. We extend it like so. And there we go. That's x plus y equals 5. All right, now we're going to do the same thing for x minus y equals 1. I should move this across over here. X minus y equals 1. So again, let x equals 0. 0 minus y equals 1. Y equals to negative 1. This is going to be our y-intercept. This is our y-intercept. Now we're going to look at y equals to 0. So we have x minus 0 equals 1. X equals to 1. This is our x-intercept. All right, perfect. So now plot these 2 points. We have y equals negative 1. X equals 1. So that's like very, very close in terms of the graph's position. But it still gives you the shape. If you look at it, you still know the shape of the graph. We get this. We get that. I think I just got to fix the gradient up a tad. All right, it's being a bit weird, but that's fine. So we have here x minus y equals 1. I just want a degree of accuracy because of question B, but that should be good enough. All right, so I've got my graph laid out. I think it does need to be just a tad this way. All right, perfect. I think that's perfect. All right, so now with that done, we've done the sketch. Look at question B. It says read off the point of intersection of the 2 lines. So we'll just zoom in for a second. If we look at the intersection of the 2 lines, we can see we intersect at 3, 2. So that means that the point of intersection is at the coordinate 3, 2. And therefore the answer will be x equals 3, y equals 2. Or as a coordinate, you'd write 3, 2. All right, and then it says confirm your answer to part B by solving the 2 equations simultaneously. So what I'm going to do, I'm just going to shrink this a tad. So I have a bit of space to work. And one of my favorite ways of solving is Looks like my screen went blue. One of my favorite ways of solving is by using vertical elimination, or just solving sometimes using elimination. So look at that. I'm going to vertically add these. So x plus x is 2x. Now, why am I vertically adding these? It's because y plus negative y will cancel out. And then we have 5 plus 1, which is 6. And then finally, divide by 2, we have x equals 3. So that ticks the first box. We definitely have x equals 3. Now I'm just going to back substitute this into one of these. I think the first one will be fine. 3 plus y equals 5. Subtract 3 from both sides, we get y equals 2. And there we go, confirmed. Both answers showed up. Okay. Moving on. Rewind, pause, whatever you need to do. If you want clarification on anything, feel free to go back and have a look. All right, let's have a look at this question. So Look Smart Shirts charges $60 for one shirt and $50 for each shirt after this. Find as a function of n the cost C in dollars of n shirts. Okay, so basically what we have here, we have for n equals 1, or what's the best way to think about it? It's basically you have an initial cost, and then every shirt after that is $50 each. So if we buy the first shirt, that's 60. If we buy the second shirt, that's 110. If we buy a third shirt, that's 160. So these 3 points should be enough to give us an idea of how things are moving. So if you notice, this is pretty much a table of values. Cost n, and I'm just going to transform this into that table of values that I was talking about. All right, from this table of values, I can get my equation. So the equation, imagine normally we do y equals mx plus b, if you recall from year 10. But with this one, we're going to change it to the letters provided here. So normally y goes at the bottom, x goes on top. So you can clearly see I have to replace c with y with c, and x with n. Now, how do we get m and b? Remember, we're always trying to calculate for m and b. Well, let's start with m. M is actually the easiest. M is the difference between these cost values, so long as this is going up by 1. Why is that the case? Because if you use the gradient formula, so if I do 110 minus 60 over 2 minus 1, so this is like y2 minus y1 over x2 minus x1, then I will get 50. Okay, so long as this is going up by 1, then you can just see that the gradient is going to be 50. So now we have C equals 50n plus B. In order to calculate B, all you have to do is substitute any single one of these points. All right, think of these as a coordinate. So let's say we sub in 1 and 60. N equals 1, C equals 60. We get 60 equals 50 times 1 plus B equals 50 plus B, and that's 60 minus 50 from both sides, you get B equals 10. Well, there we go. So now I've got my equation. And therefore, C equals, and we're subbing B equals 10 back into here. So C equals 50n plus 10. And that's question 8 done. Okay. All right, and question B is the same as question A, just an additional question. So I think I'll actually leave that. I'll leave that for you guys to do yourselves. Let me do that. That should be plenty for that. All right. So now your homework is to complete that exercise. I think it's 3C. Yep, exercise 3C. Finish that off, guys. And inshallah, if you have any questions, just let me know on Canvas, or you can wait until we return to school. But seeing the rain, I don't know when that will be, inshallah. So stay safe, guys. I'll see you soon. Assalamu alaikum.